Imagine asking an AI to find a needle in a haystack. I mean, a huge haystack of information, like asking it to read 100 different documents and, in an instant, pull out the one that answers your question. It's a massive computational challenge, but honestly, it's one we absolutely have to solve for the future of AI. Well, it turns out, a team of researchers has been doing exactly that, and what they've found could literally change everything.
Yep, researchers from Google DeepMind and the University of Texas at Austin have been diving deep into this exact problem. They wanted to figure out how to make these large language models, LLMs, incredibly good and incredibly fast at finding that one crucial piece of information buried in a mountain of text.
The specific technique they're working with is called in-context ranking, or ICR for short. The best way to think about it is like this. You hand an AI your question and a whole mini library of, say, 100 documents all at the same time, and you just say, "Go, read all of this right now and tell me which one matters most." It's a ridiculously powerful skill for an AI to have.
Now that sounds absolutely amazing, doesn't it? I mean, the ability to process and rank information on the fly could just revolutionize everything. But, and this is a big but, in the real world, there's this massive roadblock that makes this whole idea almost impossible to scale up.
And that problem has a name. It's called quadratic complexity. So inside the AI's brain, there's this process called the attention mechanism. And the way it normally works is that every single piece of information talks to every other single piece of information. So if you double the documents, you don't just double the work. No, you quadruple it. It's like a meeting where everyone has to talk to everyone else at the same time. The whole thing just gets exponentially slower and way more expensive really, really fast.
So, the old way was clearly not going to work. The researchers realized they couldn't just keep treating the AI like some mysterious black box. They decided it was time to pop the hood, get their hands dirty, and actually figure out how the model was thinking when it tried to do this.
And what they found was pretty fascinating. Take a look at this heat map. It shows where the AI is focusing its attention. You see that super strong diagonal line? That was their first huge clue. It basically means that, for the most part, each document was just paying attention to itself. It was acting like a lone wolf, not wasting a ton of energy talking to all these other unrelated documents.
But their second discovery, this was the real aha moment. They found that these really specific, almost random-looking parts of the query, things like the colon symbol or the very last word of the prompt, they acted like spotlights. Their attention wasn't scattered around everywhere. It was focused, like a laser pointer, almost entirely on the one single correct document. You can see it right there. All that energy is just zeroing in on Doc 24, which was the right answer. They were signal carrier tokens.
So when you put those two discoveries together, the picture becomes crystal clear. The AI's brain was trying to be efficient on its own, but its fundamental programming, its architecture, was forcing it to do a ton of pointless, extra work. It was like a genius being forced to use a really clunky, outdated tool.
Okay, so armed with these amazing insights, the researchers set out to build a new, much smarter method, and they called it BlockRank. The goal was pretty simple. Build a better, more efficient brain for the AI, one that was based on how it naturally wanted to think in the first place.
So how does BlockRank actually work? Well, it's a clever two-part strategy. First, it basically hard codes that lone wolf behavior they saw. It changes the AI's attention so that documents are forced to only look at themselves in the main instructions. No more pointless chatter between documents. And second, it uses a special training trick to amplify those spotlight tokens, making them even better and brighter at pointing straight to the correct answer.
And the difference this makes, it's night and day. The old brute force way had that quadratic complexity. It just couldn't scale. BlockRank's smart, structured approach completely changes the math, turning it into linear complexity. So now, when you double the number of documents, you just double the work. It scales beautifully.
This all sounds fantastic on paper, but the real question is, did it actually work? Can you really make an AI this much more efficient without making it, dumber? Let's take a look at the results.
And the answer is a huge, resounding yes. This table shows BlockRank, and get this, it's using the open-source Mistral model, sitting right at the top of a major industry benchmark called BIR. It doesn't just keep up, it actually beats other state-of-the-art models, even some that are based on much larger systems like GPT-4. So it's not just faster, it's actually better.
And how much faster are we talking? When they tested it on a list of 100 documents, BlockRank delivered a 4.7 times speedup. That is not a small improvement. That is a massive, massive leap in efficiency.
This chart really tells the whole story, though. It's all about scalability.
As you pile on more and more documents, you can see the processing time, the latency, for the standard model just skyrockets. It goes vertical. But look at the line for BlockRank. It stays almost flat. It can handle a way bigger workload without even breaking a sweat.
I mean, the researchers themselves put it perfectly. They said BlockRank is a scalable and effective solution that can process around 500 documents, which is a huge amount of text, in under a single second. Just incredible.
So let's zoom out for a second. Because this isn't just a cool piece of engineering for AI nerds, this has really huge implications for the future of how all of us find and use information.
What this all boils down to is that this research just smashed through a major bottleneck that was holding AI back. By making this kind of massive information processing dramatically faster, cheaper, and more energy efficient, it puts these incredibly powerful tools within reach for way more people.
So what does this actually let us do? Well, imagine an AI that can scan an entire archive of scientific papers instantly to help find a cure for a disease. Think about powerful, affordable tools for students that can sift through hundreds of sources for their research project. Or even just a personal assistant on your phone that can actually read the entire 300-page manual for your new camera and tell you exactly how to find that one setting you need. This is a huge step towards that future.
And all of this leaves us with one last, really powerful question. We are building AIs that can read and comprehend vast libraries of human knowledge at speeds we can't even imagine. So the question isn't really if the AI can find the needle in the haystack anymore. The real question is, what incredible problems are we going to ask it to solve next?